Yes, today I'm going to explain about the polar method, polar line coding. In that polar line coding, okay, it contain bypass polar. Okay, that bypass polar again it have the two types of method, that is Manchester and differentiate Manchester techniques. Okay, then what is a Manchester technique? The Manchester technique, okay, it is it is a combinations of non-return to zero level and non-return to zero line coding method. Okay, see here, like each and every transaction it will be happen at the middle of the like a middle of the bit. Okay, that middle of the bit, it may be a from higher to lower or lower to higher voltage. Okay, it uses two set of voltage levels, that is I have told, right, that is the higher to lower voltage and lower to higher voltage. So based on that we have to draw the timing diagram. Okay, I'll show how it is we supposed to draw the diagram. And then before that, what is the differentiate Manchester? That differentiate Manchester encoding, it is going to contain, or it is going to combinations of NRZI as well as the non-return to zero. But Manchester is NRZ level, means non-return to zero the level, as well as the return to zero technique. Both the technique they have used at the Manchester, but differentiate Manchester, it can use the non-return to zero inversion as well as the return to zero scheme. Okay, this is the major difference between the Manchester and the differentiate Manchester. Then here differentiates Manchester, every signal, okay, or sorry, every symbol, okay, it is going to taking the transaction at the middle. Okay, it's same as the Manchester also, but the level of the signal, it is going to happen, or it is going to determine by the symbol value. Okay, that value should be a causes, it should be, the value should be a higher to lower or lower to higher. Okay, but one symbol causes a level changes, the otherwise it does not. Where the level should be changes and which value, okay, it is going to change the levels, we will see in this differentiate Manchester. Okay, see, this is the Manchester and differentiate Manchester. Here the Manchester, I have told it is a combinations of NRZL and RZ. Okay, NRZL, the same technique we supposed to use here. See, before that it is going to divide the two levels or two halves of the voltage here. One is upper level and lower level. Okay, it is the signal, it is going to divide into two sectors or two levels here. See, one is upper layer and lower level. Like that it is going to divide the voltages here. Okay, the both the Manchester and differentiate Manchester. Okay, based on that it is going to we are going to draw the signal diagram. Then say if it is 0, okay, if it is 0, the transaction will be happen from higher to lower. Okay, if it is 1, the transaction will be happen from lower to higher. Okay, the Manchester encoding, the durations of the bit is divided into two set of voltage, okay, or two offs. The voltage remains at one level during the first half and move to the other level. Okay, this other level of the second half. The transition at the middle of the bit provides this synchronization. Okay, the this synchronization we call it as a differentiate Manchester. The differentiate Manchester, in other hand, it like we are going to call it as a RZ as well as the NRZ inverter. Okay, see, it is going to combinations of these two technique we supposed to draw this diagram, or means timing diagram. Here, the Manchester and differentiate Manchester encoding, the transition at the middle of the bit is used for the synchronization. See, the middle of the bit, okay, the middle of the bit, it is going to happen the synchronization. I'll tell you how it is how we can draw the timing diagram. Okay, the Manchester, it contains the 0. Okay, 0 means higher to lower, 1 is lower to higher. Okay, see this one you have to keep it in mind. See if it is 0, higher to lower, right? Within that time slot. See these all are the time or delay. Okay, this like the dotted line, it shows the time or delay. Okay, within that time the transaction it should be completed. See if 0 value, it contain higher to lower. Yes, if it is 1, yes, see look at this, lower to higher. If it is 0, yes, lower to higher. If it is 0, yes, yes, it should be a higher to lower. Yes, if it is 1, see it's a lower to higher. Like that we have to draw the Manchester diagram. Okay, see based on this symbol we supposed to draw this. Okay, then what is the differentiate Manchester? The differentiate Manchester, it should be a like inverse of our NRZL as well as the RZ. Okay, means should be a ulte of our RZL. In this time, in differentiate Manchester, the 0 value will be lower to higher and 1 value will be, okay, higher to lower. Like that means it is the inverse of our Manchester method. See, you look at this differentiate Manchester. If it is 0, see if it is 0, it should be a lower. See, the transaction, it should be happen that is within that midpoint. See the midpoint, it is going to synchronize here. See, you look at this, synchronize here, it is going to start the transaction from lower to higher, but our Manchester is higher to lower. See the difference it here. Okay, lower to higher. Again, if it is 1, yes, it should be a higher to lower. Again, if it is 0, yes, within that time or within that delay, okay, we have to get the transaction. Okay, means we have to complete the one transaction, completing one cycle. Again, if it is 0, yes, we supposed to complete one more transaction. See where it is going to start it from here. Okay, from here it is going to start at the transaction. See this complete one cycle, because one is higher to lower. Okay, it is going to start from this end to the next end, means it is going to complete one transaction. Like that, see it is going to complete one transaction. Again, if it is 1, yes, if it is 1, it should be a higher to lower. See, if it is 1, it is a higher to lower. Like that, okay, we have to draw the Manchester and differentiate Manchester line coding. Then what is bipolar? The bipolar, it can contain the two types of technique, that is AMI and pseudo ternary technique. Okay, that AMI technique we call it as a, yes, we call it as a AMI technique. Okay, that we we supposed to use that AMI technique is the alternate mark inversion. Okay, the alternate mark inversion, we call it as that AMI technique. Okay, the AMI and pseudo ternary, okay, it is a common bipolar encoding schema, is called the bipolar AMI technique, that is bipolar alternate mark inversion. Okay, here the alternating mark inversion, it is it is come from one of the Greek word. Okay, here if we are going to take the voltages, okay, that is if it is 0 voltage, okay, that value will be 0, and if it is the high voltage, okay, we are considered as the value will be 1. Like that, based on this value we supposed to use the so timing diagram here. Then before that, what is the pseudo ternary value here? The pseudo ternary, which the bit value 1 is encoded as the 0 voltage